Hello, this is Sasank, roll number 152, and today I'm going to solve the question, find the Laplace transform of f of t equals t. Laplace transform of f of t equals t. So before finding the Laplace transform of f of t equals t, I'm going to find the Laplace transform of f of t equals 1. That is, L of 1 equals integral 0 to infinity e power minus st 1 dt, where t is the parameter and e power minus st is the kernel. So that becomes minus e power minus st by s 0 to infinity. Now e power infinity, when e power it becomes e power minus infinity when we plug it into the kernel, so that is 0 minus of minus, that is 1, e power 0 is 1 by s for all s greater than 0, because we are integrating from 0 to infinity. That becomes 1 by s for all s greater than 0. Now we are going to use this in finding the Laplace of f of t equals t. L of t equals integral 0 to infinity e power minus st t dt, where this is the kernel. We can integrate this using the by parts method, where we assume t as u and e power minus st as v, following the Eilert convention. So by simplifying this, we get t by s e power minus st 0 to infinity minus integral 0 to infinity minus 1 by s e power minus st dt. We know that s is a constant, and this is a very interesting scenario, because when infinity gets plugged into e power minus st, it becomes e power minus infinity times infinity by s, but this takes the higher precedence. E power minus infinity obviously becomes 0 because it's a very, very small number, so that is 0 minus, well, 0 by s times 1, so that is 0. So this whole part conveniently gets turned to 0, and now that gets cancelled out, so we have 1 plus 1 by s 0 to infinity e power minus st dt. Well, this is Laplace of 1. That gives us 1 by s times 1 by s, that is 1 by s square for all s greater than 0. Thank you.